All right, guys, day 2 of the unit circle. Today we're going to be doing some video notes. So if you have to pause, if I'm going too fast, or maybe rewind if you miss something, you can always do that as far as the video goes, but please be sure that you're taking these notes so you have all the information that you need. All right. So this one says, what if we don't know the angles or the angle and we aren't using one of our special right triangles? Well, what we have to do in this case is we're going to create a triangle with our given information. And then we're always going to use a reference angle, which goes from the x-axis to the terminal side. I'll show you what that means here in a second. All right. That's going to help us create our new angle, our new right triangle. Okay, so if I do an example, that's probably the easiest way to show you kind of what's going on. This one says, find the 6 trig functions for angle theta in standard position if a point with the coordinates -15, 20 lies on the terminal side. And so what we need to do here is really pay attention to our negatives. All right, sometimes these are going to be positive, sometimes negative, sometimes a combination of both. And so in this case, -15, 20, if I were to graph this on a normal XY plane, that'd be back 15 and up 20. All right, I think we'd all agree with that. And so what this does for me, I'm going to label my sides here, -15 and +20. And if I connect the other two kind of endpoints to make a triangle, then I have a right triangle. All right. However, of course, this does not have a radius of 1 if I were to draw the circle around. And so you can still find our 6 trig functions, which we're going to do today, but they're not going to be as nice as they were using just the unit circle. Okay, so let's first maybe find our missing side length over here. I'm using the Pythagorean Theorem. This is just a right triangle. So what I can do to do that is call my -15, I'll call it a squared. My b squared is the 20 squared. Then equals, maybe I'll call this x for the time being, x squared. For the c, the hypotenuse. And -15 squared is 225. It's nice that the negative kind of becomes positive when you square it there. And then 20 squared is 400. Equals still x squared. All right, 225 plus 400 is 625, and that happens to be a nice square number. When we take the square root of it, we actually just get 25. Okay, in fact, if you know your 3, 4, 5 right triangles, this up here is a 3, 4, 5 right triangle, all being multiples of 5. So this is a 25 for this hypotenuse. Okay, once we know those, then it's really easy to fill in our sine, cosine, tangent, cosecant, secant, and cotangent based off of our triangle. Okay. Now, one thing that we need to kind of mention here is that our thetas in each of these triangles we're going to make today are going to be the angle that's closest to our origin. So I'm going to put my theta right here, just so you don't confuse it with like the other angle that it could be up there. It's always the one closest to the origin. All right, so sine compared to my angle theta down here, sine is opposite over the hypotenuse. In this case, 20 over 25. And if you can simplify this, please do so. 20 divided by 25 is the same as 4/5. Okay, 4/5. Cosine of theta, that's going to be -15 over 25. -15 over 25, which simplifies to be -3/5. And tangent of theta would be 20 over -15. 20 over -15 simplifies to be -4/3. Okay, and then of course our cosecant, secant, and cotangent, we can just flip it with its corresponding sine, cosine, tangent. So for example, cosecant is going to be 5/4. Okay, secant is going to be -5/3. This negative, don't think of it as being on the top or bottom, but think of it more as like out front. Same thing for this one. The whole thing just stays negative. And then cotangent is going to be same thing, -3/4. Right, that negative there is out front. All right, easy enough. Let's try another one. Okay, this time I have -5, -4. So if you were to plot these points, this is actually going to lie down here in quadrant 3. Okay, -5 is my x value. Then if I go down 4, it look like this, and come back. So this is -4. Make it a little better, -5. All right, and then my theta is the closest one to the origin. So here I need to use the Pythagorean theorem again to find my hypotenuse, just like this. Let's see, this gives me, it's going to be 16 plus 25. If I square those, equals x squared. That is 41 equals x squared. And so x is just going to be the square root of 41. We do want exact answers, so please leave it as the square root of 41. That one cannot be simplified anyway. All right, sine of theta, here again was my theta. Sine is the opposite over the hypotenuse. All right, this is going to be -4 over the square root of 41. Remember, we need to rationalize our denominator. Take it times the square root of 41 over itself. And this is, let's see, negative, I'll put it up here for the answer, negative 4 square roots of 41 all over regular 41. Okay, cosine is going to be negative 5 over square root of 41. Notice here back in my other one, don't work harder than you have to, okay? We already did one almost identical to this where we start off with negative 5 or negative 4 in our first case over square root of 41. So our answer is really going to be almost identical, just I'm replacing the negative 4 with a negative 5. Negative 5 square roots of 41 over 41. You can check my math, make sure that is correct. Okay, tangent of theta is going to be negative 4 over negative 5, opposite over adjacent, which negatives will cancel and just be 4/5. All right, and then we can go and flip these for our bottom trig functions. Let's see. And so this one, I think it'd be easiest if I flip this version of it to get me to have negative square root of 41 over 4 for cosecant. Secant, same thing. I'll probably flip this version, which is negative 41, negative square root of 41 over 5. And then lastly, cotangent is just 5/4. Okay. All right, let's try another type of problem. All right, this one says, suppose an angle is in standard position whose terminal side lies in quadrant 4. All right, so it's going to be over there. It says if secant of theta equals the square root of 29 over 5, find the values of the remaining 5 trig functions of theta. So it says remaining 5. They already gave us 1. We can fill that in right away. This is the square root of 29 over 5 for secant. Okay, and let's see here. So I'm going to make my right triangle. This always kind of goes back, if you have your diagonal line, this always goes back to the x-axis. Never go over to the y. That will not be correct. Always goes to the x. Okay. And what's it tell me? It says secant. Well, secant, remember, this corresponds with cosine. And so if I were to flip this, right, I know that cosine is actually going to be 5 over the square root of 29. Now, I know that's not correct right now. The square root's on the bottom. But for the sake of putting this in my picture, it'll help out a lot. All right. Cosine is the adjacent side, which is 5. And then the hypotenuse is the square root of 29. Make my pen a little smaller. There we go. Okay, so same idea. Now it turns into really just a problem like we've been doing, where I need to find that third side of my triangle and then fill in the rest of our trig functions. Okay, so let's do that. Let's use the Pythagorean theorem. This time, this is probably going to be my x. So we have 5 squared plus x squared equals the square root of 29 squared. Okay, so 5 squared is 25 plus x squared equals, here the square root and the square just cancel, giving me 29. If I subtract 25 over, I think that's x squared equals 4. And so x, of course, would have to be 2. Now, this is where it's tricky, because if you were to plot this point, I'll use a different color here, plot this point down here, this would be 5 and then something negative. I have to go down in order to get to that point. So I can't just throw in a 2 there. I have to actually say negative 2. Okay. In fact, x squared, if I do take the square root of that, really this equals plus or minus 2. So it is possible to use that negative case, especially depending on which quadrant you're in and where your point is going to be. All right, in this case, we need a negative. All right, let's fill in our other trig functions really quick. Sine of theta now is going to be negative 2 over the square root of 29. Of course, that is not simplified. We need to move our radical to the top by rationalizing our denominator, giving me negative 2 square roots of 29 over 29. Cosine, very similar. This time it is 5 over the square root of 29. And if I rationalize the denominator here, 29 square root of 29, this is 5 square roots of 29 over 29. My 9s kind of look like 7s. There we go. Okay, and then tangent of theta is opposite over the adjacent, negative 2/5. like that. So if I flip all these, let's see, if I flip cotangent real quick, this is -5/2. And the other one that I need is cosecant. Again, I'm probably going to go back to this version where I still have a negative out front, but then I'm going to flip the square root of 29 on top and the 2 on the bottom. All right, easy as that. And of course, this is the one they gave us in the problem. All right, one more problem here, and that is cosine of theta equals -1/2, and this is going to be in quadrant 2. So quadrant 2 is over here. So start with your diagonal and always come back to the x-axis, making this my right triangle. Theta goes closest to the origin. Remember, we've been doing this all along. All right, and now it says cosine of theta. Well, cosine of theta is the adjacent side right here over the hypotenuse. And so in this case, I can put this as -1, which is good because it is going to the left, right? And then a 2 on the hypotenuse. So real quick, let's use the Pythagorean theorem to find our third side. Let's see here. We have -1 squared. I better put that in parentheses. Plus, I'll call this x squared equals 2 squared. This is 1 plus x squared equals 4. Subtract 1 on both sides, and x squared equals 3. So I think we're going to have the square root of 3 instead of x. All right, I'll go back to my blue color. There we go. Let's fill these in. Sine of theta is going to be the opposite over the hypotenuse, or in our case, the square root of 3 over 2. It's already good. We don't have to simplify that at all. Cosine, -1/2. I think this is the one they gave us in the problem. Yeah, cosine is -1/2. Tangent, it's kind of on the side over here, but I'll put it below it. Tangent of theta is going to be the opposite, square root of 3 over the adjacent -1. Let's put our negative out there, which is just going to be negative square root of 3. If I simplify that. Okay, cosecant, flip and simplify. This is now going to be 2 over the square root of 3. Oops, so I have to multiply this by the square root of 3 over itself, giving me 2 square roots of 3 over 3. Secant, just flip 2 over -1, which is -2 if I simplify. And then lastly, this is going to be -1 over the square root of 3. Again, rationalize your denominator. Last problem here. And this gives me negative square root of 3 over 3. Okay. Hey guys, if this was helpful to you, you might want to check out this video I put on the screen for some more of these trig functions. Otherwise, we'll see you in the next one.